This is the solutions for linear algebra and programming skills, Unit 6G4730002, and this is the 2016 summer examination. You'll be asked to answer 5 questions, and it's a 3-hour examination. So the first 4 questions are on linear algebra. So first of all, we'll cover question number 1. So the first part of the question 1a is concerned with matrices and 1b is concerned with vectors. So the solution is over here on the right. So question 1a, we're given 2 matrices A and B and want to determine, if possible, A times B. Now A is a 3x3 matrix and B is a 3x1 matrix, so we can multiply these 2 matrices together. So all you have to remember, to get the element in row 1, column 1, we multiply row 1 by column 1. So we'd have 1 plus 9 take away 4. So 1 plus 9 take away 4 is 6. To get the element in row 2, column 1, we multiply row 2 by column 1. So we'd have 1 plus 0 plus 2. That would give you 3. And finally, to get the element in row 3, column 1, we multiply row 3 by column 1. So we'd have 0 plus 12, take away 6, so that gives you 6. So that is A times B. To find the cofactor of 4 in A, so here is the element 4, we remove row 3 and column 2. So that leaves the elements 1, 1 and minus 2, 1. We find the determinant of this 2 by 2 matrix, which gives us 1 plus 2 is 3. And then because the element 4 is in row 3, column 2, 3 plus 2 is 5. So we need to multiply it by a minus 1. So the cofactor of 4 in A is minus 3. If we want to solve for x, when ax is equal to b, then we have this system. So this equates to 3 simultaneous equations in 3 unknowns. We can use row reduction, or you can use the inverse matrix method, whichever you prefer. Here I've used row reduction. So here we're going to alter row 2 to get rid of this leading 1 here. So we alter row 2, and it looks like we've done row 2 take away row 1. So row 2 goes to row 2 take away row 1. So that gives us 0 there. 0 take away 3 is minus 3. 1 minus minus 2 gives you a plus 3. And then 3 take away 1 gives you 2. So that's our new row 2. Now we want to get rid of this element here, this 4. So we're going to alter row 3. Okay, so you alter row 3 and you can get rid of that 4 there. So it looks like we've probably done something like 3 row 4 plus 4 row 2. 3 row 4 plus 4 row 2 will get rid of that 4. And that gives us this new row 3. Once we've got to this stage, then we can read off z is 14 over 3. Once we know z, we can then back substitute in this second equation to find y. And once we found y, we can then back substitute for z and y to find x. So this is the solution for x, y and z. For 1 part B, we're now dealing with vectors. So A and B are 3-dimensional vectors. To determine A take away 5B, we simply take our vector A and then take away 5 times the vector b. So you should understand how to do scalar multiplication of vectors, and then we just subtract corresponding elements. So the first element in the new vector is minus 1, and then it'll be minus 10. So minus 1 minus 10, the first element is minus 11. And then you can do this similar to find the second element and the third element. So this is the resulting vector A minus 5b. To find A dot with B, okay, so we're taking the vector A and we're dotting with B. Remember, we take the first elements, multiply them together to give minus 2. And then we add the second elements multiplied together. So minus 1 times plus 1 is minus 1. And then we add the third elements multiplied together. 5 times minus 5 gives you minus 25. Add those 3 together, we get minus 28. To find the length of the vector B, so this is the Euclidean length. So the length of the vector 2i plus j minus 5k, we just simply square each of the elements, add them together, and then take the square root. So we have the square root of 2 squared plus 1 squared plus 5 squared, and that gives you root 30. So that is the length of the vector b, and that's with respect to the Euclidean norm. And in the second year, I'll show you different norms. So that's something to look forward to in the second year. The final part of the question, we want to determine a unit vector perpendicular to A and B. So we need a cross product. So to find a cross product, we find this determinant. And remember, it's important that you put the vector A in the second row and the vector B in the third row. So we find this 3 by 3 determinant. So the component I, we have 5. Five there, take away 5, so the first component is 0. For the j component, we have a 5 and then minus 10, which is minus 5, but then because it's the j, we negate that, so that gives us plus 5j. And finally, to find a k component, we have minus 1 times 1 is minus 1 plus 2, so minus 1 plus 2 gives you plus 1. So there is a vector perpendicular to A and B. To find a unit vector, we then divide by the length of this vector to give the vector 0, 5, 1 divided by root 26. So this is the unit vector. And of course, if this vector is perpendicular to A and B, then the negative of this vector is also perpendicular to AB. So there are two possibilities. That concludes the solutions to question number 1.